Now, thermodynamic first law basically tells you that the increase in internal energy of a system is equal to the heat absorbed by the system as well as work done on the system. Now, written in equation form, it is this one. Now, when you go and read this, you may be reading it as change in internal energy equals to change in heat supply plus change in work done. This one is not supposed to be read that way because when it comes to each of these variables, they have a specific meaning to them if they are positive or negative. If you're talking about heat, delta Q, it will be positive if heat is absorbed by the system, but negative if heat is released by the system. And then when you're talking about work done, delta W, it is considered to be positive if work is done on the system. Work is done on the system when there's decrease in volume of the system. It is considered to be negative if work is done by the system. In such a case, usually there's an increase in volume of the system. So it will be easier to try and understand this from the example of a balloon. Say, for example, you have a certain balloon that's filled with gas. That gas will continuously try to push out against the balloon, okay? So if you purposely apply some sort of force to squish the balloon, what happened will be that that balloon will decrease in volume. Okay, let's just say you use your hand and then you try to squash the balloon, it will decrease in volume. It will reduce in size. Okay, so that your balloon now from this size, it becomes this size. Okay, it's a smaller volume right now. Okay, so in such a case, we would actually say that you have done work on the system. Okay, when you go from here to here, there is volume decrease. You are actually doing work on the system. This one is volume decrease, work done on the system. Okay, why is work done on the system here is because in order to decrease its volume, you actually have to purposely apply some sort of force to decrease its size. So this is work done on the system. Okay, it's because you did work on that system, that's why the volume has actually decreased. Okay, now if you again look at that same balloon right now, and then you again assume that there is gas that's contained inside the balloon. Say the pressure inside the balloon is very large, is very great, such that if you just leave it there, the balloon suddenly expands in size to something like this. Okay, so in such a case, you let the balloon expand. You did not have to purposely apply a force to squash the balloon into a smaller size. The pressure inside the balloon itself was very great to the point that it can actually expand by itself. So in such a case, your balloon actually has a volume increase. That volume increase wasn't because you purposely apply a force to increase its volume. It's because the gas inside the balloon itself apply a force to expand the balloon. So work is not done on the system right now. Work is done by the system. Okay, so this is work done by your system. Okay, so that's the reasoning why we say that when you say work is done on the system, there's actually a decrease in volume, and work is done by the system, there's an increase in volume. For work done on system is considered as positive work. For work done by system is considered as negative work. Okay, and then when it comes to internal energy delta U, sometimes I tend to write IE as internal energy. Okay, sometimes the U, the symbol U here is also considered as internal energy according to your textbook or your syllabus. Okay, so they are actually referring to the same thing. IE or U, they are referring to the same thing. And because you just went through gravitational field, U here from the previous chapter was GPE, right? So just be careful about certain symbols as you go along in A2, you could be using same symbols, but they are referring to different things entirely. Okay, so the U here that you see, don't mistake it as GPE, is actually referring to a separate quantity called internal energy. So for internal energy, delta U here is considered to be positive if the system gains internal energy, but it's considered to be negative if your system loses internal energy. So now, if you look at the equation at the top here just now, I mentioned to you that it's not supposed to be read as change in internal energy equals to change in Q plus change in W. It's supposed to be read as increase in internal energy is equals to heat absorbed by the system and work done on the system. Because when you write it like this, when you write your equation like this is all by convention already assumed to be positive. Because let's just say I told you y is equals to a plus b, this one is already considered to be positive, this one is already considered to be positive, right? Usually when you try to write a variable, so x, this one by right is already considered to be positive. So here, when you just write the variable there like that, it's already assumed to be positive by itself. So each of this variable here is considered to be positive. So you have to use the meaning attached to the positive of each of these variables. So your system has increased in internal energy equal to work done on system plus heat absorbed by system. Okay, so that's the meaning here. That's why we call it like this. That's why it's defined like this. And then after that, when it comes to work done, there's one thing here that you should know. When you're asked to calculate work done, there's a particular equation that you will use to calculate work done. This is under the condition that you have constant pressure, okay, and a corresponding change in volume. If you want to find work done under constant pressure by a certain gas, delta W is actually equals to pressure times change in volume. This is actually the same equation that you have seen in your AS physics when you're talking about work done by a gas. So that equation is also still applicable here. So same like your AS is only applicable for constant pressure cases. Okay. Now, if there's no volume change in your gas, there's no work done. Okay. So just be careful of that. All right. So let's just do some past year question.